Welcome to our review on conservation of mass. Now, first thing we actually need to understand then is the law of conservation of mass. So, quite simply, what that states then is that atoms are not created or destroyed in chemical reactions, therefore the mass is conserved. Now, what that actually means is, even when a chemical reaction takes place, we're not making new atoms or destroying them in some way. So, what that tells us is, however many atoms we start with, we must have in our products as well. So the mass of our reactants is going to be the same as the mass of our products. To illustrate this point then, we've got a little equation here that shows you how the masses remain the same. So we start off with our silver nitrate reacting with sodium chloride to make silver chloride and sodium nitrate. So if we work out the relative formula masses for each of those chemicals, what we have, our silver nitrate is 170, sodium chloride 58.5, and then for our products, our silver chloride 143.5, and our sodium nitrate is 85. Now, if we then take our two reactants and add up their masses, we get a total mass of reactants of 228.5. If we do the same thing on the right hand side of the arrow for our products, we also get 228.5, which shows us that we've got exactly the same mass for our reactants as the products. Therefore, mass is being conserved. The kind of question they could ask you here then is to work out what mass of carbon dioxide we make. Now what they'll do is they will give you the chemical equation and they will give you two of our three masses. So what we can see there is we've got our copper carbonate on the left, which has a mass of 123.5, and one of our products, our copper oxide, has a mass of 79.5. So carbon dioxide is the only other product we make. So quite an easy calculation here. We take the mass of our reactant, 123.5, and subtract the mass of the one product we know, which is 79.5. So our calculation there then, 123.5 minus 79.5 gives us the mass of carbon dioxide, which is 44.